For number 1 here, we see the parentheses, which should always scream at us, do something here first. There's only one set of parentheses. We check and there's nothing that can be done inside the parentheses. So what needs to be done to the parentheses is multiplying by the 6. So I've got the 5x up front here. Nothing's going to happen to that. 6 times x is 6x. What do I have to put in here? It's a positive 6x. I do have to put plus there. 6 times negative 3 is negative 18. Now, before I do anything on the right side, there's more I can combine over here. I can combine 5x and 6x to make 11x. I still have the minus 18. On the right side, there's nothing to do with the 15, so I'm just going to leave 15. So now to solve this, I would add 18. Very good. 11x equals 33. And then divide by 11. X equals 3. Any questions on that one? How many of you had 3 for that one? How many have no idea where 3 came from for that one? How many want to cry and go home? There's always a few. I can muster up a tear if it'll get me out of here. Yeah. So number 2, there are a couple of different ways we can approach number 2 here. One way is to make the x over 4 into 1/4 x. Dividing by 4 is the same as multiplying by 1/4. And I can make the x over 7 into 1/7 x. Yeah, we'll get to that in a second. Equals 22. Now I have to add 1/4 x and 1/7 x. 1/4 plus 1/7 is 11/28. That's 11/28 x equals 22 still. Now to solve that, I would divide by 11/28. X equals 22 divided by 11/28 is 56. One-fourth plus 1/7. Okay, if I want. Yeah, my common denominator is 28, right? So 4 times 7 makes 28. 1 times 7 is 7. 7 times 4 is 28. 1 times 4 is 4. 7 plus 4 is 11. 28. Now over here, the other way I could do it is I find that that common denominator is 28. I can multiply this whole equation by 28. So 28 times x over 4, well, it's 28 over 1 times x over 4. The 28 and the 4 cross cancel, give me 1 and 7. 7 times x is 7x. I do 28 times x over 7, so that's 28 over 1 times x over 7. The 28 and the 7 cross cancel, give me 1 and 4. 4 times x is 4x. 28, yeah, the fractions are going to disappear here. That's why we would do this method. 28 times 22 now is 616. So now we've got 7x plus 4x is 11x equals 616. We can divide by 11. X equals 56. Any questions? Okay. There are a couple other ways you could approach that one, but those are the 2 easier methods. Number 3. We see more than one parenthesis, so we're going to go left to right. On the left side, nothing to do in there, so we're going to multiply by the 2. 2 times 5x is 10x, and 2 times 1, positive 2. Nothing more to do on the left side, so now we're going to go to the right side. Nothing to do inside that parentheses, so we'll multiply by 8. 8 times 5x is 40x, and 8 times the negative 11, negative 88. Now that we've done, there's nothing more we can reduce on that side. Now that we've combined everything we can on each side, we step back and look, is it down to a single variable or single appearance of the variable? No, the x still appears twice. It's just on opposite sides of the equation. I'm going to get rid of 1. I will get rid of the smaller one, the 10x. I subtract 10x. I have to subtract 10x on the other side. The only place I can take it is from the 40x. So I've got 2 on the left. 40x minus 10x is 30x minus 88. Then what? Add 88. So the negative 88 goes away. 2 plus 88 is 90. Equals 30x. And then divide by 30. So 3 equals x. Any questions on that one? Going over to number 4 then. This is just as, number 4 here is no different than having, 5x plus 2 equals 72. It's just that we have fractions in there instead of whole numbers. So we're going to start out by subtracting the 6.5. That's gone. We've got 2/3 x. 18 3/4 minus 6.5 is 12 1/4. Now all that's left is to divide by 2/3. X equals, well, we've got to do the 12 1/4. Divide by 2/3. 12 times 4 is 48, plus 1 is 49/4. We just made that an improper fraction. Instead of dividing by 2/3, we're going to multiply by the reciprocal. So we'll multiply by 3/4, or 3 2s. 49 times 3 is 157. 4 times 2 is 8, which is the 157, right? Yeah, it is. 147. That's why. 147. So we divide that out, and that is 18 3/8. Yeah, 147 divided by 8. 8 goes into 14 once. Bring down the 7. That goes in there 8. That's 64. There's 3/8 left. If you have a fraction calculator, by the way, it's just fine to go ahead and just type that in and divide it out on the fraction calculator. I don't expect you to do the fractions by hand at this point. Any questions? What we're going to be looking at starting to work on today, I view as one of the most difficult topics in math to master. And that is taking words and situations and putting them into one of these equations that we've been working with. Word problems to equations, yes. Oh, shoot. So we're going to start out with some of our simpler phrases, like a phrase like 7 more than a number. So if I'm going to represent this with variables, operations, and numbers, 7 more than a number. First of all, what operation does that imply? Addition. 7 more than something implies that 7 has been added to something. Now this is one of the reason I use this example is one of the big mistakes people make is they think the order it's written is the order it has to appear in the algebraic formula. 7 comes first, they want to put 7 first. That's not necessarily so. 7 more than something can mean 7's been added to the end of it. Yeah, when it's addition, it really doesn't matter. But yes, you should have more information if you're looking at what order. More than a number, well, 7's been added to a number is what that's saying. How do I express the number? X and whatever letter I want to use for that variable. We'll use X for it right now. What other phrases out there could be used to indicate X plus 7? I'll start you out a number increased by. There you go. That would indicate X plus 7. Any others? A number plus 7. Seven added to a number. Any others? Elevated, yeah. Yep, a number elevated by 7 or 7 greater than a number. That one you got to be very careful with because if you do 7 is greater than a number, that's something very different, right? If it's 7 is greater than a number, you got 7 greater than X like that. We're not ever going to work with anything like that in this class, so you should never have anything that has the greater than or less than symbol in it when we're doing our phrases. Another one, we'll throw out the fancy word here, the sum. What's the word sum mean? It means the result of an addition problem. The sum of a number and 7. If I said the sum of 7 and a number, would it be the same thing? Yes. One's implying that the number is first and 7 is last, and the other's implying 7 is first and the number is the second thing. But when we're adding, the order doesn't matter. If it's subtraction, it's a different story, yes. Like if we have a number decreased by 4, how would I write that with variables and X minus 4? Again, we could use any letter. It could be Y minus 4 or N minus 4 or whatever we want to use. Other ways we could write that, other phrases that would indicate X minus 4. 4 less than a number. Just like 4 more, or 7 more than a number, or a number increased by 7, we're adding the 7 on the end. 4 less than a number implies that the 4 is being subtracted. So it has to be X minus 4. Any others you can think of? We had decreased, but reduced. That's what you're looking for. I figured that's where you're going with it. Number reduced by 4. A number minus 4. Throw out the fancy terms again. The difference. Now here the order does matter. Difference of a number and 4. That implies that it's X minus 4. If I said the difference of 4 and a number, it would imply 4 minus X. You got to be very careful with that one. And of course, there are several other phrases if we sat here and thought long enough that we could come up with. Let's say I have a number repeated 8 times. That's multiplication. So that would simply be 8 times X or 8X. We don't need the multiplication in there. Other phrases? 8 times a number. There's the fancy word. The result of multiplying 8 in a number would work. Multiple. Yeah. Product is the one that you're looking for. The product. Oh, sure. Of 8 and a number. If you said the product of a number and 8 would also be the same thing. We could say multiply a number and 8 or an 8 and a number. When we do multiplication, we tend to always put the variable second and the number first. But again, it doesn't matter. 8 times x and x times 8 would be the same result. What if I have a number split 3 ways? That would imply division. That would be x divided by 3, or we could write it as x over 3. Yep, they both mean exactly the same thing, x divided by 3. In algebra, we tend to use this one a little bit more just because it's a little more compact. Other ways we could write x over 3 or x divided by 3. There's the one, the quotient of a number in 3. A number divided by, there we go, 3. And of course, there are probably a lot of other ways you could write that out if we sat here and tried to think them out. We're a little crunched for time, so I'm going to speed her up a little bit. And it's a little more difficult when we have multiple operations to deal with. Like, how would you write this one out? 3 times a number increased by 9. 3x plus 9. Very good. How about this one? 9 more than let's just do this easier. 9 more than 3 times a number. 9 plus 3x or 3x plus 9. Either way. So it's basically the same thing, isn't it? What if I had 9 more than the product of a number and 3? Still the same thing. 3x plus 9 or 9 plus 3x. Either way. How about 3 times the sum of a number and 9? This is slightly different. All of these will be 3 times a number. Careful. This was 3 times the number. Down here, it's 3 times the sum. The sum is the result of an addition problem. So that's implying the addition happens first. X plus 9 first, then we multiply that sum by 3. So some very subtle wording there that makes that different. Many times we'll have formulas that'll help us out with these. For example, one formula I have is the perimeter of a rectangle is 2 times the length plus 2 times the width. If we are told that the length of a rectangle is 6 more than the width, the perimeter is, oh, what do I want to put in here? 88 inches. Find the length and the width. Well, it might help draw a picture here. We have a rectangle that has a length and a width. Of course, our perimeter is 2 times the length times 2 times plus 2 times the width. And I know that the perimeter is 88, so I'm going to put 88 in for P right now. But I still have 2 variables there, and we don't know how to work with that. We have to make one of them go away. We have to replace one. Well, I'm given the length is 6 more than the width. So that's implying that the length is equal to the width plus 6. Does that make sense? So in this formula over here, I can replace L with W plus 6. So 88 equals, instead of 2 times L, it's 2 times W plus 6. Now I can solve this for W. I see parentheses, which should yell at me to do something there first. And I will. We got 2 times W is 2W. 2 times 6 is 12. And we still have the 2W over there. We'll stay on that right side. What can we combine there? 2W and 2W make 4W. So 4W plus 12. Now that's all we can do over there. On the left side, the 88 hasn't changed. It's still 88. Now we can start solving that. Yes, we will subtract 12 to get 76 equals 4W. The 12 is gone. And then divide by 4. 19 equals W. All done, right? No, we still have to make sure we answer the question that was asked. Find the length and the width. Well, we found the width is 19. That's in inches. The length is going to be 19 plus 6, or 25 inches. Now we're done. So when we do word problems, we have to make sure once we've solved the equation, we go back and actually answer the question that was being asked. So out of the book, we're looking at page 260, exercise 6.5. 1 through 25, the odd is going to be writing these expressions and equations from word problems and solving some applied problems. Next week on Tuesday, we're going to talk about mixture problems. We didn't get time to touch on those today. Then I think next week, Wednesday, we're going to wrap up Unit 4. So next week, Thursday, will be our Unit 4 test. So you're